Our next topic is inverse proportion, right? Consider a triangle whose area is fixed 20 centimeters square. Where here are some possible dimensions for the rectangle. So first of all, its dimensions will be 20 centimeters long and 1 centimeter its width, right? Again, the second one will becomes 10 centimeter its length and 2 centimeter its width. The third possibility is that 5 centimeter is its length and 4 centimeter is its width. So you can see that if the length of the given rectangle is decreased, the width of the given rectangle is increased. So by increasing the one term or by decreasing the one term, the next term is decreased or increased. So that is called the inverse relation, right? Notice that one dimension goes down in size, the other one increase. The product of two dimensions remains constant, that is xy is equals to 20, where x and y are the length and breadth of the rectangle respectively. Do you understand?
Yes.
Okay, you could also write this as y is equals to 20 over x. This type of relation is called inverse relation. This is the definition of inverse proportion. Again, you could write it as y is directly. This is the sign of proportion. Y is proportional to 1 over x. You can say in two ways. Y is directly proportional to 1 over x, or you can also say that y is inversely proportional to x. So if you use inverse, you just use x, and if you use direct, then you can use it as 1 over x. More formally, you would write it as y is equals to k over x. This is the basic difference in direct proportion and inverse proportion, that y is equals to kx and y is equals to k over x, where k is the constant of proportionality, right? Again, here is the other example of the inverse proportion, that two quantities x and y are such that y is inversely proportional to x and x is equals to 20, y is equals to 6. Find the formula that connecting x and y. Work out the value of y when x is equals to 40 and what is the value of x when y is equals to 2. So we have to solve this as, first of all, y is inversely proportional to x can be written as y this way. So when we just move this remove this proportionality sign, you can write it as y is equals to k over x. So we just put x value as 20 and y value as 6, so your value of k is 120, right? After putting the value of k into this equation, you can write it as y is equals to 120 over x. Now in the part b, you can see that work out the value of y when x is equals to 40. So y is equals to x is equals to 40, we have to find the value of y. Y is equals to 120 over x, that will becomes 120 over 40, that will equals to 3. So y is equals to 3 is your solution. Again, for part c, work out the value of x when y is equals to 2. So we have to put the value of y as 2. So what is the value of x? By eliminating x, you have the value of x, that is 60. Do you understand this example or not?
Yes.
Okay. Again, as in with direct proportion, some inverse proportion problems can involve power such as squares. So like in direct proportion, we have squares and cubes. In also inverse relations, we also have the squares and uh, cubes, right? A scientist has squirted a drop of oil on the surface of container of the water. The oil has formed a circular patch and is slowly expanding. This thickness of the circular patch of oil is inversely proportional to the square of its radius. When the patch has radius 3 centimeters, its thickness is 60 microns, right? 1 micron is equals to 1 cross 10 raised to the power minus 6 meters. At any time, the radius r centimeter and the thickness d microns. Write down a formula connecting d and r. So you can see that the proportion is, since d is inversely proportional to r squared, right? So its answer will be written as d is equals to, d is proportional to 1 over r square, right? So we can write it as d is equals to k over r square. So we just put the value of r and d. So your answer will be k, that is 540. So r's value is 3, d's value is 60. When we put 60 is equals to k over 9 because 3 square. So after this 9 goes on the other side and multiply by 60. So k's value is 540. Therefore, the required formula is d is equals to 540 over r square when we put k's value into the equation, right? Again, you can see that we have to find the value of d when r is equals to 6. We just put value of r is equals to 6 into this equation. So your answer will be 15 microns. And the next one is d is equals to 1. That we have to find the value of r square. So r square will be equals to 540. So if we take the square root on both sides, its answer will be 23.2 centimeters, nearest to 3 significant figures. This is the example. Now we have the next exercise, that is 21.2. Same process, but the formula is different, right? You have to do question number 2, question number 3 part D, question number 5, and the last one question number 8. You have to do these questions quickly, then we will start the next. Okay, so first of all you have to do the examples also. Do you have any problem till now?
No.
Okay, that's enough. You have to do examples and then tell me.